screen for you guys that are at home. Now, I know it says you try it, but since it's our first example for today, I thought maybe we'd do it together. All right. Yesterday, as you guys are jotting this example down, I want to remind you, yesterday we said that substitution is more reliable, isn't it? And it can be, when we practice it enough, it can be more time efficient. Okay? I mean, the graphing takes a while, but substitution can be pretty quick if you're good at it. And it is very accurate. It will give you the answer that you want without much uncertainty at all. There was a step-by-step process by which we said you should go through substitution. That first step is to pick a variable in one of the equations and isolate it. And I'm wondering if, does anybody remember what I recommended? Tiago, what variable did I recommend you guys get by itself? Yeah, very good. If you can find one that's got a coefficient of 1, or maybe it is going to make it easier because you won't have to divide by anything. We can just use simple subtraction or addition and be straight. So which one would that be for us on this example? X in the first equation. So watch what happens. When we get X by itself in this first equation, just over here kind of in my margin area, I'm going to get X equals 4y minus 4. Okay? What did I do, Reed, to get X equals 4y minus 4? What did I do to both sides of that first equation? Yeah, we just added 4y. Just moved the 4y term over to the other side. We changed signs. Now I'm going to take that expression, and Luke, where am I going to plug that expression in? Very good. We plug it into the other equation. We plug it into the other equation because if we plugged it into the first equation, it would we would not be getting anywhere. It'd be just like a dog. I think he said yesterday, it'd be like a dog chasing his tail. So we're going to take this expression and we're going to substitute it in for X into that other equation. Okay, and that's going to produce a new second equation. Here's what that new second equation is going to look like. It's going to be -3. Instead of -3x, it's going to be -3 times something. 4y equals 0. And what is that something? 4y minus 4. 4y minus 4. Perfect. 4y minus 4. Okay. Now we've taken it for, y'all remember we talked about a 2-by-2 system, right? 2 equations in terms of 2 variables. Now what we've got is we've got 1 equation in terms of 1 variable. Substitution allows us to take something from a 2-by-2, a big system, bring it down to a more comfortable 1-by-1. That will be the same approach that I take with you guys when we start looking at 3-by-3 systems. And there's 3 equations and 3 variables. We'll use substitution, for example, and we'll bring a 3-by-3 down to a 2-by-2, and we'll be on comfortable ground then, and then we'll take the 2-by-2. Because everybody and their brother should be able to solve what I've got highlighted right there. Okay, we should be able to. So, Paul, what's your first step on that highlighted equation right there? Yeah, we're going to distribute that -3. We get -12y plus 12 plus 4y equals 0. And then we're going to combine like terms. Nate, do that for us. Excellent. And I'm going to go ahead while we're at it, I'm going to subtract 12 from both sides. You cool with that, guys? Of course you are. And then we're going to divide by -8. Negative over negative is positive. And it looks like that's 3 halves. 4 goes into 12 thrice and goes into 8 twice. So we get y equals 3 halves. Is it okay that I get a fraction as my answer? Yes. All right, very good. And Joey, are we finished? We are not finished. We got to go back and find x. Now, truth be told, you could plug y equals 3 halves now into either of the black equations to find x. But why not plug it into the one over on the side here, right where we already know x is isolated. X is already by himself. Right? So x equals, instead of 4y minus 4, it's 4 times 3 halves minus 4. So that's going to be 6 minus 4, also known as 2. And then, Joe Edwards, how do I write up my final answer? Joe, I think you're muted still.
I thought you said Joey, not Joe.
No, Joe Edwards. Go ahead. How do I write up my final answer?
2, 3 halves.
Yeah, very good. 2, 3 halves. And that's my ordered pair. That's the point of what? The point of intersection. All right, very good, very good. Any questions on this basic example of substitution? Is this something you guys have done in y'all's classes yet? No. Just kind of new-ish, totally new. Okay, cool. Hey, when you get to it in your class, I want you to be the expert, okay? You will have practiced, hopefully. You will have practiced enough with me to where when you get to it in your class, you know, you can help your classmates out. When the teacher's asking questions, you know, you'll know exactly what to do. You'll know exactly what those answers are. Jack? No, you don't have to. So like the question, if you didn't hear it, was do you have to use improper fractions? So like you could do 2 comma 1.5. Do 2 comma 1.5. Typically in algebra, the improper fraction is the conventional way of looking at it, though. You know what I'm saying? But no. If you put like 2 comma 1.5, I wouldn't count off at all. All right. But we do want to get comfy with those improper fractions. Good question there, Jack. Now, there's to go sort of finish this lesson up, there's a couple of special cases, special scenarios that once in a while we run into. You might remember those from your notes as being where those two lines, graphically speaking, the two lines were parallel. How many points of intersection do parallel lines have? 0. They don't have anything. Okay, no solution. Or what was that other one? Infinitely many. Graphically speaking, where would we get infinitely many points of intersection? Yeah, they're the same lines. One line right on top of the other. It's coinciding lines, the exact same line. So if you have your wits about you, you can sometimes identify that early on. You could look at it and you could tell that whether they're parallel lines or whether they're lines that coincide the same line. If you can spot the slope as being the same, then it'll trigger a little red flag in your head, and you'll say, oh, that's one of those special cases. Okay. But what I like to do is I want to pretend like we don't see that yet. Okay. And perhaps we don't. So let's just run this like we would normally do on this example 3 here. And I'm probably going to get y by itself in the first equation, like we said a moment ago. Right. So let's go ahead and do that. So I got y equals 2x minus 3. At this point in the game, fellas, I don't want to be too harsh, but at this point in the game, I shouldn't have to explain how we got y by itself. Okay, so hopefully you guys get that. And then we're going to take that 2x minus 3, and we're going to substitute it in place of y into the other equation. So I got negative 6x plus 3. Instead of y, we got 2x minus 3. And then just like in the last example, right, we're going to distribute. So we got negative 6x plus 6x. 3 times negative 3 is negative 9. And negative 6x, positive 6x. And we're left with negative 9 equals negative 9. Okay? Now, at this point, you might be thinking, well, dadgummit, wait a minute. That's like a dog chasing his tail. Did you plug it into the right equation? We did. We plugged it into the other equation. Our expression came from the first equation. We plugged in the second equation. And what we got here is called an identity. This is called an identity. And an identity in math, fellas, is a statement that's true no matter what. No matter what I plug in for x in that equation, it was going to be true. It doesn't matter if I plug in x equals 1 or x equals 2 or x equals 3 or x equals 4 or whatever, x equals 42 billion. Okay, it was going to be a true statement no matter what. So when we get an identity, actually what we now know is that this is a system where there's going to be infinitely many points of intersection. Okay, so this means that that's that dependent system, infinitely many solutions, we would say. Let's do that. Infinitely many solutions. And that's because it's what we call a dependent system. Make sure I spell things correctly here. I know that spelling isn't hereditary, but my son stinks at spelling just like I do. And it is a struggle every day. All right, now if we had, like I said at the beginning, had our wits about us, we probably would have recognized that these were the same equations, right? Check this out. What would have happened? Let me clear a little bit of this out of the way. And what would have happened if I had initially here divided everything by negative 3? Watch this. Watch what happens. Okay? Negative 6 over negative 3 becomes 2x. 3 over negative 3 becomes minus y, and then -9 over -3 becomes 3. And that was the exact same equation as the first one. So that's why they're lines that coincide. There's kind of hiding in plain sight that these were the two same lines, so there's infinitely many solutions, okay? But we found that because we got an identity. What you'll get in the other special case isn't called an identity. It's called a contradiction. Watch what happens. In this case, we've already got y by itself in the first equation. So let's just plug that in for y in the second equation. You guys jot this down with me here. So we got 2x minus 5. Instead of 5y, it's going to be 5 times that expression. 2/5 x minus 4. All right, here we're going to distribute. Charlie, what exactly are we distributing here? Good, I love it. He said distribute the negative with the 5. We don't want to get out of that good habit, right? So that negative with the 5, I'm going to have 2x to start with, and then the 5s are going to cancel, so it's minus 2x, and the -5, -4 is going to be positive 20. And then we got 3. The x's are going to cancel out. And then here we've got 20 equals 3. How do you feel about that, Alex? That ain't true. That's balderdash. Hogwash. Okay? That's what's called a contradiction. When I was a kid, probably your age actually, my mother would tell me to do something. She'd say, honey, go fold your laundry, or go make your bed, or go take out the trash, or whatever. And I'd say, but Mom. And she'd say, don't contradict me. Okay? Don't butt heads with me. Don't go against what I say. A contradiction like 20 equals 3 goes against everything that we know about numbers. Okay? And so when you get a contradiction, no matter what you plug in for x, you're never going to make it true. 20 will never equal 3. Okay? So this is an example where there is no solution because those lines are parallel. They have the same slope but different y-intercepts. There's no point of intersection on those two lines. Does that make sense, you guys? All right, how many of you guys have done the graphing homework on Delta Math? Anybody? Oh, boo, bad. Like 3 of you guys? Shameful. Hey, look, I put up some homework on this section as well, on substitution. And you guys have that, and I think I've got it set to do as Monday. Hey, please be doing your practice work. You will not get better at this unless you're doing the practice work. If I log on to Delta Math and I see a bunch of deadgum zeros on you, I know you ain't working for me, okay? And I've been there, done that, learned my lesson. We talked about my 8th grade math experience, right? Have I told you guys that? George is nodding his head. George, what was my 8th grade math experience? I probably did. I had a teacher named Mrs. Edge. She had a glass eye. Can we talk about that? No. Oh, she was well, she might not have had a glass eye. I can't remember. She might have had just like an eye that was kind of pointing in a different direction. But anywho, she was a really, really good teacher, but she was super tough. And I had her as 8th grade algebra teacher. And I was always really smart and good at math. And then I got to 8th grade algebra, and I was just like, I didn't have any work ethic. I'd always just kind of like sat and paid attention to my teacher and been like, yep, I can do that. But in algebra, this honors algebra class, it was kicking my butt, y'all. I mean, it was like just destroying me. And part of it was because I wasn't going home and doing my homework every afternoon. Like, I wouldn't do the homework because I thought, I got this. And I don't remember if she took homework up or what, but like come test time, I mean, I was nosediving, just bombing these tests. So she sent home an interim. We were talking about what happened when the interim came home. He just heard this from his brother or something. I don't know, but they sent home an interim. She sent home an interim saying, hey, Mr. Morgan, you're failing this class. Please get your mom or dad to sign this note letting them know that you're failing this class. Because this was back in like 1998 before the like online grade books and stuff. So anywho, I knew that my dad would kick my butt if I brought home a failing grade. And so what did I do? I forged his signature. Dun, dun, dun. Terrible mistake, right, Nate? Terrible mistake. But I thought I was a clever little 8th grader, so I signed it just like I'd seen him sign things before and turned it back in, and I thought, Miss Edge is so foolish, she'll never know the difference. And she didn't. I got away with it for about 2 more weeks. And then I kept failing, kept not doing the homework, and in 2 more weeks, she upped the ante. What did she do? Instead of sending a progress report home, she ring-a-ding-ding, she called home. And I can remember being an 8th grader, probably about this time of year, as a matter of fact, okay? It was very reminiscent. How old are y'all? 13, 14. Okay, so that would have been about 22 years ago. Okay, been a long time. Anyway, I can remember sitting on my bed playing with an Etch-a-Sketch. I don't know why I was playing with a daggum Etch-a-Sketch, but I was playing with an Etch-a-Sketch, and all of a sudden, I heard my dad on the phone. All of a sudden, I heard him say the words, "What interim?" And I knew that my goose was then cooked. And so he came storming down the hall after the phone call and said, "Boy, what have you done?" And so I fessed up. And my punishment, I got, y'all ever lifted weights before? You ever seen anybody lift weights with a big leather weightlifting belt? You know what that is? Okay. I mean, it's ginormous. It's got this, Joe's nodding his head. He's like, "Oh, yeah." You know, it's like this thick leather. Okay. And it's got a huge buckle. So this was, I got whoopings when I was a kid. So this was the last whooping that Coach Morgan ever received. Okay, ever. Last whooping I ever got was in the 8th grade. 10 licks with a weightlifting belt on the booty. Okay, and that learned me my lesson. I also got grounded for a buttload of time, but I also got booted from Mrs. 8th grade algebra class. Okay, so she was like, "Dude, this is not working. You go over to Coach Boren and you take your quote 8th grade math class, and then you'll try again next year with the algebra." So I did. I tried again next year as a 9th grader. Mrs. Edge did not teach me 9th grade algebra. Who did I have for 9th grade algebra? I had Mrs. Gibson, or rather Miss Gibson. Okay, Miss Gibson had just graduated from Ole Miss. Miss Gibson was a cheerleader at Ole Miss. Miss Gibson was a beautifully well-endowed young lady, we'll say. And so I sat in the front row and I paid close attention. Everything Mrs. Gibson said, "Yes, Mrs. Gibson," or "Miss Gibson, I will do that homework. Yes, I'll be happy to stay after school and get tutoring. Yes, ma'am." She was gorgeous. And I passed Algebra 1 as a 9th grader thanks to Miss Gibson. And you know, I was off to the races. But I learned my daggum lesson, didn't I? Do the homework, or else you get booted out of my class and into some, I don't know, beautiful 9th grade algebra teacher. Oh, Lordy, good stuff. But that is a true story. 100% of that is a true story. Learn from my mistakes, you guys. All right, what I want to do now, this is just some scratch work, so I didn't want that. Okay, what I want to do now is I want to talk about our third technique, okay? And our third technique is going to be another one of those upon which we can rely very steadily. It's called elimination. Elimination. Sometimes it goes by the name linear combination. That's kind of a boring title. I like elimination. Makes me think of the Terminator, right? The Terminator, "I will eliminate you, take you out." Okay, y'all seen those movies or some TV show or whatever? So elimination is where we're going to get rid of something. We're going to eliminate one of the terms. Here's how it works, though. I got an example I want to pull up from what we did yesterday. I want to find it, though. Where is it? Where is it? Where is it? Perfect. Here it is. And what we're going to do is we are going to do the same example. We already know what answer we're supposed to get, so this will be nice. There we go. Now, here are a couple of notes for you guys to jot down about elimination. Now, we talked in substitution. Paul, make sure your nose is covered up, please. We talked about substitution, how it's kind of smart to isolate the right variable, and we went through a step-by-step approach. Here's what I would recommend for elimination. Number one, please make sure that everything is lined up in columns. So standard form is the way to go. In other words, put both equations in standard form. Okay? Put both equations in standard form. Now, thankfully, it's set up for me right now like that. Okay? Once both equations are in standard form, we're going to pick a variable to eliminate, to get rid of. Here's how you're going to do that. You're going to look ahead. You're going to channel your inner Magnus Carlsen. Y'all know who Magnus Carlsen is? World #1 chess player. He was a chess prodigy when he was a little kid. Now he's grown up and he's kicking booty. Magnus Carlsen. Anyway, what are chess players able to do? They're able to look several moves ahead, right? All right. All right, so we're going to look ahead and we're going to think to ourselves, which of these variables could I get to have the same coefficient but with different signs? Okay, I'll type that up because that's sometimes hard to remember. We want the same coefficient with different signs. Okay? We want the same coefficient with different signs. What that means is that if I have like a 7x, I want a negative 7x on the other equation. If I have a 10y, I want a negative 10y on the other equation. Okay? Now, the way that we can do that is by using the multiplicative property of equality, right? Which pretty much says I'll do what I want. As long as I do it on the left side, I do it on the right side. So, like, watch what happens. Suppose that I wanted to multiply everything on this bottom equation by 2, okay? Suppose I wanted to multiply everything on this bottom equation by 2. What would that do? That would give me 12x minus 2y equals what? Equals 16. I have now produced a new second equation. I've produced a new second equation that has my y terms lined up, ready to go. Do I have the same coefficient with different signs now? Yes, I do. All I had to do was multiply one of the equations by a constant, left side, right side, and now it's set up good. Once you have that, all you have to do is tally up. This is why they call it the linear combination method. All you have to do is tally up the columns. We've got it lined up in nice, neat fashion, right? We've got it where my x's are all in a column, my y's are all in a column, my constants are all in a column. So let's tally things up. What's 4x and 12x? 16x. What's 2y and negative 2y? That's the elimination. We have eliminated one of the variables. We've taken it from a 2 by 2 system. What's 16 and 4, by the way? We've taken it from a 2 by 2 system and brought it down to a 1 by 1. Can you solve 16x equals 20? What do you do to both sides? Divide both sides by 16, and we get 5/4. Oh, BT dubs? 5/4 was part of my answer. So we know we're on the right track. What we've done in elimination is that we have picked one of the variables. Everything's lined up. We've picked one of the, we've said, let's get their coefficients to match, just one positive, one negative. And then once that's the case, just straight down the columns, tally everything up, you eliminate that variable, then you've got a 1 by 1, an easy equation to solve. And then once I've got half my answer, all I got to do is either plug that into any of the equations that I like, or set up the system again and eliminate the other variable as you like. All right, what was this? What was it originally? 6x minus y equals 8. That's what it was originally. So if I eliminated the y variable, now I want to try and eliminate the x variable, okay? Can you guys figure out the least common multiple of those two coefficients in the x column? Least common multiple between, what is that, 4 and 6 is 12. So what would I need to multiply the top row by in order to get 12? 3. Let's do that. Let's multiply this top row by 3, and we'll get a new top row. What is that? 12x plus 6y equals 12. Now, I got 12x. How about, what do I want to multiply on this bottom row then? 2. What kind of 2? Why negative 2, Alex? We want, now this is kind of an optional thing, right? We want a, we want for our coefficients to be the same value, just different signs. And so I always tell my students, go ahead and put the negative in there as needed. So negative 2 times 12 is negative 12x. Negative 2 times negative 1 is positive 2y. And then negative 2 times 8 is negative 16. Okay, see how that works? And then all we got to do is just tally up all 3 columns. The x column now is set up good to cancel out, to eliminate. And here we got 8y, and here we got negative 4. So y equals negative 1/2. And then, oh my goodness, look. We've got both parts of our answer. So we would come up, we'd say, hey, look, here's your answer. 5/4, comma, negative 1/2. I got to be honest with you guys. I'm a big fan of elimination. I like elimination more than substitution. Okay? Both of them will work every time. Both of them will work every time. It's just something about elimination I find to be a little bit quicker. Okay, to be a little bit quicker. That's the same answer that we got over here. By the way, we've done this one correctly. Why don't you guys try? Now I will actually make you guys try this on your own. We know what answer we're supposed to get: 2 and then 3/2. Why don't y'all try this one on your own? We did this one earlier, and instead of substitution, let's try elimination. Okay, everything is lined up in standard form already, so try and figure out how to eliminate x and try to figure out how to eliminate y. Morning session. Oxley, what variable are you eliminating? All right, so Jake is eliminating the x variable. Lewis Thomas, if I want to eliminate the x variable, what do I need to multiply on the top equation? What do you think?
Multiply y.
That's what I'm asking. What would you multiply by to try and get these two terms right here to have the same coefficients?
Oh. I thought they were supposed to both have different signs.
Yeah, true that. I mean, as far as the value goes. So, like, in other words, this is 1x right now. There you go. Let's multiply this top equation by 3. And that'll produce a new top equation, won't it? That'll give me, let's see here, we'll do this over on the side in green. 3x minus 12y equals negative 12. And then down at the bottom, I don't have to mess with the bottom one. That's kind of nice. 4y equals 0. We can stack it up and knock it out, right? What do we get? Negative 8y. And then when we divide, we get, what's 12 over 8? 3/2. And that's half our answer. Okay, fabulous. Thank you, Lewis. Thank you, Jake. Andrew, when I want to eliminate my y variable, do I have to multiply by anything? Oh, isn't that nice? That's why I like elimination, is because it's very quick, and especially if something like that happens. So if this is already prefab set up good to go, let's eliminate y. And what do we get? Negative 2x equals negative 4. Divide both sides by negative 2, and we get x equals 2. Wham, bam, thank you, ma'am. There's my answer. 2, 3/2. And we're done. To me, that's much quicker than substitution. Now, there are times where substitution makes more sense. I think we saw an example, like example 4, where they've already got one of the variables isolated. I'd probably go ahead and use substitution in that kind of example. But like an example what you guys just worked, where the original system is prefab set up good to cancel out. Are you kidding me? Elimination all day, baby. Okay. Now, we did talk about those two special cases and how when you have a special case, sometimes you get to working on it and you're not really thinking about it, and then you reach this sort of identity or contradiction. Same thing will happen with elimination. All right, same thing will happen with elimination. Check this out. If we were going to work this problem again using elimination here, I would go ahead and I would multiply the top row by 3. All right, and watch what happens when I multiply that top row by 3. That top row is going to become 6x minus 3y equals 9. All right? What happens? The x's cancel out, the y's cancel out, so that means I've got 0 on the left, and over here the 9's cancel out, and I got 0 on the right. 0 equals 0 is called an identity. Therefore, we're going to say infinitely many solutions. All right? Down here, if we had, let me rewrite this one in real quickly in standard form. Be negative 2x plus 5y equals negative 20. It's negative 20. So I just multiply everything by 5 and then subtract the x term over. Yeah, that looks good. And then what do we have? 2x minus 5y equals 3. So that prelim step of getting it in standard form. All right, so here, what do we got? The x's cancel out, the y's cancel out, so that means I got 0 on the left, and I got negative 17 on the right. Does 0 equal negative 17? No, that's called a contradiction. Therefore, we have no solution. So those two special cases, they work the same way, right? It's just having your wits about you and realizing what that means when you have an identity or when you have a contradiction. That's important, okay? So in a nutshell, what we've done thus far this week is we've talked about solving a system by graphing. Kind of takes a while. It can be inaccurate. We've talked about solving a system using substitution and elimination, okay? And you want to practice using those 3 techniques over the weekend, okay? You got any questions? Go forth. The class has ended. Live Jesus in our hearts. All right, fellas. Thank you so much. You boys that are at home, have a good weekend yourselves, and I will see y'all on Monday.